Hi everyone, today's goal is to understand direct variation. Direct variation is a linear function that can be written in the form y equals k times x, where k doesn't equal 0. K is also known as the constant of variation. The constant of variation, k, equals the rate of change for data. What else is this known as? And it has a number of different names and ways to represent it. This is also known as the slope. The slope can be expressed as delta y over delta x, rise over run, the change in y over the change in x, and our slope formula, y2 minus y1 over x2 minus x1. They all basically represent the exact same thing. Graphs of direct variation will always pass through the origin. Here's some examples. All of these lines represent equations that are direct variation. The ones in purple are not, because these do not cross through the origin. What do you need to do to tell if this equation is a direct variation? What form is it written in now? Right now, it's in standard form. To see if it's direct variation, we need to put it in the form of y equals kx. In order to do that, the first thing we're going to do is move our 5x over to the right side of the equation. We're then left with 3y equals negative 5x. We need to get y by itself, so we're going to divide each side by 3. The resulting equation is y equals negative 5/3 x. This is in the form of direct variation. So the answer to your original question is yes. It is a direct variation. Here's another example. Does this represent direct variation? Again, we need to get y by itself. So we're going to subtract 2x from both sides. We're left with negative 3y equals negative 2x. We have to get y by itself, so we're going to divide each side by negative 3. And we end up with y equals 2/3 times x. So yes, this does represent a direct variation equation. What about this one? 2x minus 3y equals 1. Again, we need to change our format for this and get y by itself. We're going to subtract 2x from both sides, and we end up with negative 3y equals negative 2x plus 1. We're going to divide each side by negative 3. And our equation is y equals 2/3 x plus negative 1/3, or minus 1/3 if you prefer. This is not direct variation form. So the answer to this would be no. We could actually stop doing our work here at this point, because you can see we have a plus 1 on this side. This would represent, when the equation is in slope-intercept form, the y-intercept. If the y-intercept is 1, that means that the graph of this equation is not going to pass through the origin, and it will not be a direct variation. Given the following information, can we tell if y varies directly with x? And here we're just given a chart. And you notice the x, the independent variables, are not consistent on this one. However, they do go up by 4 each time. To determine if y varies directly with x, write the coordinate pairs as a ratio comparing y to x. So even though these are consistent x values, they are not consecutive. So we're going to use y as 1 and put it in a ratio over negative 2 Our next one becomes negative 1 over 2, and our last, negative 3 over 6. Your next step is going to be to change all your ratios to decimals. If the decimal values are the same, your y varies directly with x. So negative 1/2 turns into negative 5/10. We have another negative 5/10, and yet another negative 5/10. So y in this case does vary directly with x. You can use this ratio to substitute in for your k value. And this would be your equation. Y equals negative 5/10 times x. A direct variation equation passes through a point 4, 5. What's the equation of the line? Well, we know direct variation has to be in the form of y equals k times x. So all we have to do is substitute the given x and y value and then solve the equation for k. That will give us our slope or our constant of variation. So we have 5 equals k times 4. We need to get k by itself. So we're going to divide each side by 4. And our constant of variation is going to be equal to 5/4. Our equation then is y equals 5/4 times x.